So properties of rational exponents are the same as properties of integer or whole number exponents. What we're going to see in this lesson are exponents with number bases, though, instead of variable bases. So that can be a little confusing also. So my suggestion is really just that if you're having a hard time, maybe put it in simpler terms. For instance, you guys would know that a to the n power and times a to the n power, you would add them. So you guys would know that x to the third times x to the fifth equals x to the eighth. You don't try to multiply x times x, you just keep that base and add the exponents. Well, that's what you want to do in this lesson also. So like when you have 5 and a half, or 5 to the 1/2 power times 5 to the 3/2, you don't multiply 5 times 5 and get 25. You keep that base of 5 and say, okay, still 5, but the exponent or power is 1/2 plus 3/2, which is 4/2, which we can say is 2. And then 5 squared is 25. So my suggestion is that if you know this is 5 and 5, maybe just make it x and x. Make them variables if that's easier to you. But the same rules still apply. If you have a power on the outside, you still distribute that in and multiply. If you have a negative exponent, it still gets moved to the bottom. All those rules are still the same. So we're going to go ahead and look at some multiplying problems first. So if we look at number 1, 12 to the 1/8 times 12 to the 5/6. Now the problem with rational exponents is that you guys also need to know how to operate with fractions. So knowing that you want to add those exponents is good, knowing how is even better. To be able to add fractions, they have to be like denominators. So if we have an 8th and a 6th, we need to make them like denominators. I'm going to make them 24ths. So we're going to make this 12 to the 3 24ths times 12 to the 20 24ths. Now, they're the same base, which is good. So we can keep that base of 12 and say, okay, 12 to what power? 12 to the 23 24ths. Now, what we don't want, just like we don't want negative exponents, we don't want exponents that are fractions. So now that we've made this one term, we're just going to rewrite it in radical form. So the 12 is going to be underneath there. This would be the 24th root of 12 to the 23rd power. So we just rewrite in radical form. But you have to know your exponent rules and how to work with fractions. So, how about number 2? 5 to the 1/3 times 7 to the 1/4. So we're going to just make this 3 a fraction by putting it over 1. And then when you multiply fractions, we do top with top, bottom with bottom. So 3 times 1 and 1 times 3. So this will become 5 to the 3/3 times 7 to the 3/4. 5 and 3/3 just is 5 to the 1st, so that just stays. We're going to rewrite this as 7 underneath there, 4th root of 7 cubed. And again, it doesn't matter if you have the cubed on the outside or the inside. Still the same. Both the same. So 2 to the 6th times 4 to the 6th, all to the negative 1/6 power. So again, you can make these fractions by putting them over 1 if that's helpful to you. So this becomes 2 to the negative 6 times 4 to the negative 6. So they just both become negative 1. But you can't have negative exponents, so we're going to actually move both of them to the bottom of the fraction and make this 2 to the first times 4 to the first on the bottom. So 2 times 4 on the bottom will be 1/8. So again, it's tricky because you have to know fractions and your exponent rules. So if we take a look at number 6, 6 to the 1/2 times 4 to the 1/3, all to the power of 2. So again, put that 2 over 1. And this will become 6 to the 2/2 times 4 to the 2/3. So again, 2/2 is just 1, so this just becomes 6. And we're going to rewrite this as the cubed root of 4 squared. Now, we should have 4 of the other problems, but because they were so large, I did not worry about it. But 4 squared is really just 16, right? So this becomes the cube root of 16, and there's a perfect cube inside there. 8 and 2. 8 is your perfect cube. So this cube root of 8 is 2 times the 6 on the outside will be 12. Cube root 2. So when you're doing these, you do want to check and make sure that you can't simplify any further than what you've done and find any perfect roots inside there. Also, don't forget to put your little index, because if you don't put the index, I'm just going to assume that you think it's a square root, and it might not be a square root. Like we just had a cube root. It might be a 4th root. So just pay attention to those little things. So let's just do one more, number 8. And the properties of radicals, we've discussed these before, but if you look in the box, just remember that depending on if it helps your situation, you can either put things together or separate them when you're multiplying and dividing if they have the same root. So just keep that in mind. And what we've been doing, a radical is in simplest form if there's no perfect nth powers left underneath there, or the denominator does not have any radicals left in it. So number 8, one more multiplying problem. If it's helpful, and in this case it is, to multiply 12 times 18, 12 times 18 is 216. Well, 216 is a perfect cube. 6 times 6 is 36. And then if you multiply that by 6 again, you get 216. So the cubed root of 216 is 6. So in this case, it was helpful to not necessarily simplify them separately, but to multiply them together and then go from there. I know the reason you won't like these is because everyone is a little different, and each one can be solved a little differently also, to be honest. You might be able to solve it a little differently than the person next to you, but you should always end with the same thing. But when you're multiplying, if you have a number base, it needs to be the same and you just keep that value, then you use your exponent rules for the powers. So again, if you get confused, maybe just use variables as a simpler concept for the same problem.